Yeah. Yes.
Okay. Well, thank you for the opportunity to give this presentation. As you can see, I'm doing it with my colleagues, and this is part of a much larger study that we did that was funded by the Australian Research Council and with the Department of Education in Queensland. I'm not going to read the title out, you already have the title, so I'll just move along quickly. The background to this work is really, it's a policy question that's just driving us. For some time in Australia, I've been around a long time and I keep seeing the same issues come up over and over again. And more recently, as of last week, there was even more concern in the Sydney Morning Herald. So it's not a dead issue. There's continuing concern about an insufficient supply of science and particularly STEM teachers as well. And also, I'm sure Colin would say maths teachers. And there are potential consequences for teachers who may not be qualified to deliver science curriculum. Now, we draw up on Jackie Eccles' work on expectancy value, motivational theory, which highlights that among students, perceived talent, enjoyment, perceived usefulness, and costs such as anxiety and stress affect their learning behaviours in STEM domains. We have found over many years now of researching longitudinally that teachers' motivations also affect their reported teaching behaviours, and we wondered how might these be affected for teachers who are required to teach science out of field and what might be the consequences of that. So the research questions were, do science teachers' attitudes to science, reported teaching practices, and professional engagement differ for those teaching science out of field? A good question, you might say. But we also were interested in this question of the case of the partially out of field teachers who are teaching a different science to the one they undertook during their tertiary education and qualified to teach. And we wanted to pursue this question. We looked at differences among using Manover to look at the differences in attitudes, practices, and engagement. And we were able to look at also how do potential differences in science attitudes relate to reported teaching practices and thereby their professional engagement. And we looked at some Pearson correlations to undertake that. Queensland, which is where the study was conducted, Australia is a very, very, very large, geographically large country, and Queensland is a geographically large state. So when we undertook this work, it was with the teachers in Queensland, particularly in the STEM area. Having said that, we were subject to, as the researchers, we weren't able to get direct access to the teachers, but it was an online survey that was the Queensland Department of Education insisted on sending out via what they call STEM champions in the 7 regions. And they took responsibility for supporting, these people took the responsibility for supporting the STEM teachers in those areas. So it was sent out via a web link, and teachers actually completed it in their own time. Now, in-field, how we defined in-field was that we looked at, having collected all this data, the tertiary science preparation and the sciences that teachers taught, and if they matched, we called them in-field. Teachers who were out of field were teaching a science, but they had no tertiary background at all in the sciences. And those who were partially out of field were, interestingly, teachers who had undertaken a different science than they had had a tertiary background in. So they were teaching a science that was quite different to their tertiary background. The interesting thing here is that we ended up with only 7 out of field people across all of these areas. And I want to highlight this, but despite the fact that we only ended up with 7 out of 133, we did begin to see, and we did see insights into aspects of their behaviours and teaching behaviours. So the measurement instruments we used in an online survey, we looked at science attitudes, which were derived from the PISA 2015 study, which is the first time teachers are ever included, and I'll talk about this a little later. We looked at reported teaching practices in relation to that as well, and then professional engagement. You'll see that there are single items, and we've given example items. The reliabilities are quite good. The only one where the reliabilities are not so good are on the question of surface learning. However, we did get some insights using that. And of course, depersonalization, which comes from the burnout instrument, or the Maslach burnout instrument, is particularly bad for teachers, as you can see from the example item here. So here are the example items. Where there is no alpha, that means it's a single item that we use, so perceived talent, etc. So attitudes, practices, and then engagement. The depersonalization one, I treat some students as if they were impersonal objects, is a particularly interesting item because it does tap something of significance for us. So in terms of science attitudes, you can see, and here, as well as the significant differences that we were able to detect, we're also giving you where there was a trend towards significance. So it's quite interesting to see that out of field were lower than in field, and partially out of field on talent, which is probably not surprising. Also tended to be lower on enjoyment, and lower as of both partially out of field and in field. No differences on usefulness, and despite the appearance that cost might be different, there's no significant difference. Reported teaching practices then, again, we derive these from the PISA study, 2015 study, looking at the question of teacher-directed. Teacher-directed largely means the teacher is more in control of the content and the course of the lesson. It's much more expository in terms of instruction, information mainly delivered by the teacher, but it involves class discussion and demonstration of ideas which are moderated by the teacher. Inquiry-based, which of course has become extremely popular, looks at a number of ways in which teaching practices are undertaken and develop with teacher less engaged in direction. The positive associations with student attitudes has been demonstrated by the PISA data, and you can see there we've given the reference to the Mustafa study where they looked at some of these issues. But disorderly classrooms were shown that science classrooms that were disorderly, students performed worse in inquiry activities. In surface learning, you probably recognise all of these things as being what we would refer to as surface learning, and these we wanted to look at as well. So in terms of reported teaching practices, you can see teacher-directed, out-of-field teachers were lower, and they were also lower than both the out-of-field and the partially out-of-field. Sorry, they were lower than the in-field and the partially out-of-field. What alarmed us to some degree was that amongst the whole sample, inquiry was low, and surface learning was almost as high, reportedly high, as teacher-directed. In terms of professional engagement, job satisfaction didn't differ. However, turnover intent was higher for people who are out of field, higher than in field and also higher than partially out of field. In terms of depersonalisation, this was a trend, we would say, trended towards higher for the out of field teachers, were higher on depersonalisation of students. Okay, in terms of the conclusions then, the differences between the different groups, lower perceived talent for the out-of-field teachers, so science attitudes that were less desirable for out-of-field teachers, and a trend to deport less enjoyment of science. These are probably not startling findings given that they have no background in science. Reported teaching practices out of field were lower, more reliable, beneficial practices and less use of teacher-directed practice. And in terms of professional engagement, they were less desirable for out-of-field teachers in terms of higher turnover intent and higher levels of depersonalisation. Now, the low numbers of out-of-field teachers certainly would underestimate the potential effects of these people. And we can't be sure really the way the survey was distributed and the recruitment process, whether this is a representative sample at this point. However, I'm going to show you some correlations which we think are of interest. Now, the solid highlights talent and teacher directedness, and the dashed lines are those that are P is higher than 0.10. So in terms of enjoyment promoted job satisfaction and also perceived usefulness in terms of usefulness and towards an inquiry, promoted inquiry. Perceived science talent reduced the anxiety and stress and undermined the teacher-directed practice. That where you've got stress and whatever, it would undermine this teacher-directed practice. Teacher-directed instruction was associated with higher job satisfaction and also lower depersonalisation, which is a good story in terms of talent and recognition. In terms of relationships, differences in attitudes to science mattered for teaching practice and also for professional engagement. So enjoyment was lower for out-of-field teaching. It went via usefulness, which was related to inquiry practices. Enjoyment was also promoted teachers' job satisfaction. Perceived talent, which again was lower for out-of-field teachers, was associated with stress and anxiety about science and reduced teacher-directed instruction. In other words, out-of-field teachers didn't feel that they could actually directly instruct and teach the subject. Reported teaching practices associated with professional engagement then, teachers who engaged in direct instruction were those who experienced greater job satisfaction, lower levels of student depersonalisation. In other words, they were the people who were much more easily able to relate to students and not to make them impersonal objects as part of their teaching. Out-of-field teachers were lower on direct instruction and job satisfaction and higher on depersonalisation. So all of those relationships are correlational, but however, they do give us some very clear indications. In terms of policy and practice, one of the questions we would ask is in the context of Australia and in the context of government schools in Australia, is it really realistic to expect there will be no out-of-field teaching of science in government schools? And perhaps it's time for some form of contingency planning that takes this into account. Where does out-of-field most happen and for whom? Well, we have done another study this year with Chandra Shah, and we looked at the PISA data from 2015, which was looking at Year 10 students in 732 schools, and the prevalence, now allowing for the fact that science is not disaggregated in this data at the Year 10 level, which would be expected in Australian schools. There is no indication of partially out of field, which was a bit of a shame in some ways. But what do we know? Well, 6.2% of the 8,000 or nearly 9,000 teachers teaching Year 10 science, more mid-career teachers in schools with fewer resources were likely to be teaching out of school, out of field. Out of field teaching was less likely to be among teachers who are older than 50 and less in non-government schools. Our interpretation of this is that better funding allows them to compete more effectively for qualified teachers in a very tight labour market and hence fewer staff shortages. This has led us to the question, could Professional development and resources assist out-of-field science teachers, especially in regional and remote areas where the problems are more chronic. These would need to be costed at a policy level, costed to ensure teachers could undertake this as part of their work. In other words, just piling more on teachers would not actually solve the issue. And we don't know. We could find no evidence to help us understand how principals and school leaders decide to assign out-of-field teaching in science, or indeed probably in any subject, but that's beyond our concern here. How do principals and school leaders ensure that students do not have a sequence of teachers over several years who are assigned to teach science out of field? So the implications for further research then, do teachers assigned out of field science generate students' knowledge and understanding, interest and engagement in science or with science? We don't know. What are the cumulative effects for students having out of field science teachers across multiple years? In regional areas, that's very likely to be the case. What is the cumulative effect then, an impact for teachers being assigned to teach out of field and indeed partially out of field on their professional engagement and job satisfaction at different stages of their career? It seems to us we need to consider some of the chains of influence and predictive relationships, outcomes among attitudes, teaching practices, and teachers' own professional engagement, all of which would seem to us to be important, and begin to take account of some of the other contextual variables that are definitely in operation beyond the ones we've looked at. We also think that partially out of field may be the important group of people to study and to study them in more intensively in a much larger sample. Clearly, we need a much larger sample with more out of field people to better understand the representation and to have better power analysis available to us. Okay, thank you for your attention. I'm very pleased to have been able to do it today on behalf of my colleagues, and that's my email address.